Let's continue our Sudoku adventure with Lots of Differences by GDC. So this continues our same difference lines theme week. This will be the second puzzle. Let's go over the rules. We have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Now these lines, adjacent digits on the line have to have the same difference as all other adjacent digits on the line. So if this was 2, 3, these have a difference of 1. You just take the bigger minus the smaller. We're not going negative. So 3 minus 1, 3 minus 2 is 1. That has a difference of 1. So this 3 could go back down to 2, or it could go up to 4. Then the 4 could go back down to 3 or go up to 5. So we could do 2, 3, 4, 3, for example. We could also have a difference of 2, though, right? We don't know what the difference is, so that we have to figure it out. So a difference of 2, we could do like 2, 4, 2, 4. We could do 2, 4, 6, 4, whatever. Hopefully you get the idea. Different lines can have different differences. Now, we also have these circles that are odd lots. So a digit in the circle counts the number of odd digits on its line. So a line reading 3, 1, 2, 3 could have either of the 3's circled. So because there are 3 odds on the line. And so this would be wrong. We've circled the 1. But if I did this, this would be correct because there's 3 odds on the line, and that's a count of 3. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. And I'm just going to naively fill these odd lots as 1, 2, 3 here, 1, 2, 3 here, and 1, 2, 3, 4 here, because, and then we'll think about this for a second, but you can only have 4 digits on the line, so obviously the max odds is 4, right? But it can't actually be 4, because if it was 4, that one is even, and now we can only have 3 odd lots. So 4 is out. This is actually from 1, 2, 3. Now, if this was 1, it would be the only... Okay, 1 doesn't seem possible here, because this has to be the middle digit of a sequence, because we're not repeating. And 1 can't be the middle digit of a sequence. So if 2 was the middle digit of a sequence, we'd have to do 1, 2, 3. And if 3 was the middle digit of the sequence, we could do 1, 3... Well, if 3 was the middle digit, we'd have to be all odd. So we'd be 1, 3... Hold on. We could also... Sorry, this could be a 1, 3 pair with the 2. I don't know why I thought it had to be the top and the bottom like that. 1, 3 pair with the 2. Or with the 3, it would be a 1, 5 pair. So there's always a 1. And then either way is correct on the odd lots. These are both always odd. And I don't know if coloring is a good idea. Either not coloring, but I'm going to start that way. Now this one here, if this was a 1, then these would both be even. And so the difference between these would be an even number, and the difference between these would be an odd number, and that's no good. So we can't put a 1 there. Now, what about 3? Can they all be odd? But starting with 3, I don't think they can all be odd. No, they can be. We could go 3, 5, 3, or we could go 3, 1, 3. So that's an option. Now, how about 2? 2 odds? Again, 2 odds would have a difference of an even amount, and an odd with an even would have a difference of an odd amount. So that's not going to work. So this actually is 3. And so then this is 1 or 5, and then this goes back to 3. That's the only option. All right, and that places the 2 here, which is surrounded by a 1, 3. So that's 1 and that's 3. Wow. Okay. I don't think I need to color. 1 or 2. 1 would put all evens on here, and we'd have the same issue, where the difference between these evens would be even, the difference between these 2 would be odd. So this has to be a 2. And so there's 2 odds on here. They're going to be these ones, so that we can have the same difference. So these are an odd digit, and 5 is the only one available. So we're going to go 2, 5. We're going to go 5, 2, 5, 2. Difference of 3 has to just keep bouncing between the same 2 digits. We learned that last puzzle. Because you can't increase by 3 twice. You can't decrease by 3 twice. All right, that makes this a 1. We just have this one here. We don't have an odd lot on it. Maybe we know it has a 3 and a 5 on it. Makes me want to just do 1, 3, 5. But is there any other way to have 3 and 5? Yeah, we could do 3, 4, 5. So this is never the 5, though. If this was the 5, the 3 would have a difference of 2, but then that means we need another 3. So that does place the 5 and the 3, and between the 5 and the 3, we must place a 4. Okay. So that's a 4, and then this is the 1, this is the 6. We need 1, 2, and 6 here. Cleans up a little. We did all the lines. It should be Sudoku now. assuming we're correct. Two fives look up, placing the 5 here, which places the 5 here. This is the 2. That's not a 2, placing this 2. Here I need 4 and 6. Not resolved yet. This is also 4, 6 then. And these are 4, 6. The 4 tells us that's 6, that's 4. So I got a bunch of pairs here. So 1 goes in one of these two. The 2 goes, the 2 is placed. So the 3 is one of these two. The 4 is placed here. That gives us 6. And 4 and 6. And then I need 5 and 6. So the 5 goes here and is resolved. And then the 6 goes there, and that's a 1. That's 1 and 6. Up here I do need 1 and 4. That's 1, that's 4. And then down here I need a 3, and we're done. All right, nice puzzle, GDC. I enjoyed the repeated deduction here, where an even like an even number here didn't work because these would 2 didn't work because these both had to be odd, and that would make the difference be different, which isn't allowed on a same difference line. And then we repeated it here, which was neat. All right, well, how'd you do?